we're going to be using this continuous compound interest formula really often in this first section. So I want to just take a moment to review it, make sure we understand what all of our variables represent here. So here we have the equation A equals P times E raised to the RT power. P in this formula represents your principal, which is a fancy way to say your starting amount of your investment. So this is the amount of money that you would be depositing into a bank or putting into some sort of investment. R is your interest rate, and your interest rate has to be written as a decimal, has to be in its decimal form. So really quickly, you can take a decimal, let's say a percentage, let's say 5%, and I can convert that to its percentage form by either taking that number 5 and dividing it by 100, or you can think about it if you were to take the decimal place and move it to the left by 2 spots. Either way, you'll get the same answer of 0.05. So we have to have this decimal form of our interest rate if we're going to do anything with this, this formula. T represents the number of years of the investment. So how long are you leaving that money in the bank or in that investment? And then A is the amount that your investment is worth after T years. Now, the one thing I didn't mention here is what E represents. E is actually not a variable. Remember, E is a constant. E is approximately 2.718, and then it keeps going on forever. It's a decimal that does not repeat. It does not end. It's an irrational number, similar to pi. But it has a constant value, so we're never going to plug anything in for E because E has a value. It's this 2.718. So we are going to look at a quick example where we can use this formula. We've got a bank that offers a CD that earns 1.25% compounded continuously. If $10,000 is invested in this CD, how much will it be worth in 7 years? So I want to take everything that I know and plug it into this formula, and I think about what it is that I know in this particular problem. So here I know that $10,000 is invested. That means that that's my principal. So P is 10,000. R, remember, is your interest rate. So that is 1.25%. So you can take that 1.25 and divide it by 100. Or you can slide the decimal place to the left by 2 spots. Either way, you'll end up with 0.0125. T will be the number of years of our investment. So here we're looking at a 7-year investment. So T is equal to 7. And then A, well, that's what I'm trying to find. I don't know what the amount is after 7 years. So I'm going to take all of this information and plug it into that continuous compound interest formula. So that said, A equals P times E raised to the RT. So for this problem, we've got A equals P, that's 10,000, E raised to the R, so that'll be 0.0125 times T, that's going to be times 7. Here we will want to make sure that we have an E button somewhere on our calculators. You don't necessarily need a graphing calculator in order to do that. Some of the scientific ones will do that too, but we'll want to make sure that we've got an E button there. But we can just plug all this into our calculator. If you want to break it up into smaller steps, you could maybe evaluate the power first and then kind of plug that in. But I'm just going to go ahead and plug all of this into my calculator. Here I've got 10,000 times e to the 0.0125 times 7 power, and I ended up with $10,914 and 42 cents. We'll round to 2 decimal places since we're talking about dollars and cents here. So after 7 years, my account will be worth $10,914.42. That means that I've made just that $914.42 in interest. One thing that I will mention about this formula is this is the continuous compound interest formula. You can compound interest many different ways. You could do it daily, meaning you calculate interest and add it to the account once a day. You could do it weekly. That would be once a week. You could do it yearly. You could do it once a year. You could do it monthly, 12 times a year. What we want is continuous compound interest, which means that the interest is constantly accruing. The more times your interest compounds, the better return you're going to get. So here we just need to make sure that when we read these questions, the interest rate that we're looking at is being compounded continuously. I'm not going to try and throw any trick questions at you by saying, compounded monthly or anything like that. But just be aware that there are other compound interest formulas out there if your interest is compounded, say, monthly or daily or yearly. You would just need to use a different formula in that particular case.